Hello, geometry scholars. So welcome to section 2.3. This is postulates and diagrams. So some of you are going to be really great at being able to see these visually. Some of you are going to need a little more help. But these are the objectives, as you can see. Identify postulates using diagrams or pictures, and sketch and interpret diagrams. Some of the vocabulary is line perpendicular to a plane. So you can think of that as a straight line going through a piece of paper, perpendicular. So it's not sideways or skewed, it's going directly through it. We already know point, line, and plane are three undefined terms from chapter 1. And postulate, if you don't remember, is a rule that is accepted without proof. So those are the words. Let's get started. We're going to go over 7 postulates, and they're almost obvious. Some people, every time I teach this, they say, why do we have to put this in a rule? Isn't it common sense? So hopefully you feel like this is too. If you want to be following along in your student journal, this is page 46 and 47. They're written out for you as well. So you might want to get a highlighter and color them, or whatever will help you learn them. So first we have the 2-point postulate. The example is line AB or line L. Through points A and B, there is exactly one line. Line L contains at least 2 points. The line point postulate, a line contains at least 2 points. The line intersection postulate, if 2 lines intersect, then their intersection is exactly 1 point. So in this case, the intersection of line M and line N is point C, and that's where we label it. See what I mean by common sense? If you see 2 things crossing, they cross in 1 point. 3-point postulate. Through any 3 non-collinear points, remember, they're not all on the same line. There exists exactly one plane. So through D, E, and F, there is exactly one plane, plane R. Remember, R doesn't have a dot by it, so that's why it's plane R. Plane R contains at least 3 non-collinear points. So you could draw a line through E and F, you could draw a line through D and E, but you can't draw one line through all 3 points. Plane point postulate, a plane contains at least 3 non-collinear points. The plane line postulate, if 2 points lie in a plane, then the line containing them lies in the plane. So this is like a piece of paper with a line drawn on it, a line drawn on it. And that line is in the plane, exactly. So points D and E lie in plane R, which means the line DE lies in plane R. I'm going to move this over a little bit. Okay, the plane intersection postulate says if 2 planes intersect, then their intersection is a line. So I don't have an insert, but if you've ever bought anything where the package came with things inside, or like a cup holder at a fast food restaurant where it looks like this. These are 2 planes, and their intersection is this line along here. That's their intersection. The line itself is the intersection. You can see that right there if you turn it sideways. Okay, and those are the 7 postulates that we're going to use to do these problems. So you're going to practice looking at pictures and interpreting them, and then you're going to practice saying which postulate is necessary. So first, we're going to identify these postulates. Now I'm going to try, this is a little video, and I'm going to see if the voice, if you can hear it. So I'm pressing play, letting it talk.
State the postulate illustrated by the diagram. Solution. Part A. first shows two lines intersecting and then concludes that the lines intersect at one point. The postulate illustrated by this diagram is the line intersection postulate. If two lines intersect, then their intersection is exactly 1 point. Part B. The diagram first shows two planes intersecting and then concludes that the plane's intersection is a line. The postulate illustrated by this diagram is the plane intersection postulate. If two planes intersect, then their intersection is a line.
Oh, I can write on it. Good. Okay, so hopefully you can see that. We're going to do another one. Identifying just from a picture.
Use the diagram to write examples of the plane point postulate and the plane line postulate. Solution. The plane point postulate states a plane contains at least 3 non-collinear points. From the diagram, you can see that points A, B, and C are in plane P and are non-collinear because they do not lie on the same line. So an example of the plane point postulate is plane P contains at least 3 non-collinear points A, B, and C. The plane line postulate states if 2 points lie in a plane, then the line containing them lies in the plane. From the diagram, you can see that points A and B lie in plane P, and line N containing the points A and B also lies in plane P. So an example of the plane line postulate is point A and point B lie in plane P, so line N containing points A and B also lies in plane P.
And for some of you, it's hard to see, but as you can see, right, it's visually, you can try to put your head around it. Okay, now we're going to try to identify. So which postulate allows you to say that the intersection of plane P and plane Q is a line? Which one tells you that this is the case? Is it the plane intersection postulate, the plane point postulate, 3-point postulate, or plane line? If you need to, look right here, okay? It's in your journal. So that's going to be the plane intersection postulate, right? Use the diagram to match each example to the postulate. Okay, so if I was in class with you right now, I'd be asking you, what next? Okay, so the 2-point postulate, the answers are down here, right? So I'm going to try to zoom that down a little. Okay, so a line contains 2 points. That's the 2-point postulate. So it looks like A and B right here will be a line contains A and B. That looks like that goes there. Okay. The line point postulate, I'm going to look exactly at my notes. It says a line contains at least 2 points. Oh, that must be this one here then. So what does that say? The 2-point postulate says through any 2 lines, there exists exactly 1 line. So that must be this one. And then the line intersection postulate says if 2 lines intersect, then their intersection is exactly 1 point. Okay, so line M and line N intersect at point A. Oh, so there it is right there. There we go. I think we can check it too, see? So we're going to go on. How would you rate your understanding? Yes? Maybe, or no. Yay. Okay, I'm going to keep going over here. Now, I'm going to ask you to do some sketches also. So sketching a diagram showing TV, line TV is here, intersecting PQ, which is a segment, there's no arrows on the symbol, at point W. So that segment TW is congruent to segment WV. So I'm going to show you the drawing, how you do it. Okay.
Sketch a diagram showing line TB intersecting line segment PQ at W, so that segment TW is congruent to segment WV. Solution. Step 1. Draw line TB and label points T and B. So draw a line and label points T and B. Step 2. Draw a point W at the midpoint of segment TB. So find the midpoint of segment TB and label it W. Mark the congruent segments TW and WB. Step 3. Draw segment PQ through W. So draw a segment PQ that intersects. This is a sketch of a diagram showing line TB intersecting line segment PQ at W, so that segment TW is congruent to segment WB. In this example, there are many ways you can sketch the diagram. Another way is shown below.
So that's important because you realize, like, I could have drawn it this way. As long as P's on this side, as long as it's labeled P and Q, there are plenty more ways. So we're going to keep going. So number 4, a line is a line perpendicular to a plane if and only if, that's our biconditional statement, the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So in a diagram, a line perpendicular must be marked with the right angle. If you don't see that little right angle, then it's not. You cannot assume, okay? So here's another way to look at this picture. Which of the following statements cannot be assumed from the diagram?
Which of the following statements cannot be assumed from the diagram? Points A, B, and F are collinear. Points E, B, and D are collinear. Line AB is perpendicular to plane S. Line CD is perpendicular to plane T. Line AF intersects line BC at point B. Solution. In order to determine whether the first statement can be assumed from the diagram, locate points A, B, and F in the diagram. The line AF connects points A, B, and F, so you can assume points A, B, and F are collinear. To determine whether the second statement can be assumed from the diagram, locate points E, B, and D in the diagram. No drawn line connects points E, B, and D, so you cannot assume they are collinear. For the third statement, locate line AB and plane S in the diagram. The right angle symbol indicates the plane and line intersect and form a right angle, so they are perpendicular. You can assume line AB is perpendicular to plane S. For the fourth statement, locate line CD and plane T in the diagram. With no right angle marked, you cannot assume line CD is perpendicular to plane T. For the last statement, locate lines AF and BC in the diagram. The line intersection postulate states if two lines intersect, then their intersection is exactly 1 point. In the diagram, their intersection is point B. So you can assume line AF intersects line BC at point B.
Go through that as many times as you need to until you really get, and watch the diagram color. Do that again. We're going to continue though, so here we go. So this is one of those where we're going to answer. The diagram shows line TV intersecting PQ, TV, PQ, at W, so that TW is congruent to WV. If PW and QW are congruent, how can you indicate that in the diagram? Put midpoints on each of them? No. Put right angle marks on each of them? No. Put double tick marks on each of them? Yes. Since these already have single tick marks, you need double tick marks for the next one. And it's not going to be arrows either. So, yes. Okay, we have a bunch of questions here. The diagram shows TV intersecting, same question. Name a pair of supplementary angles in the diagram. So remember, supplemental makes a straight line. So one of the things you could do would be right here. Those make a straight line. So that's PWT and TWQ. So that's going to be the first one. And you can also say this line here. Right, so this is TWQ and QWV. So TWQ and QWV, like that. And we're just going to explain like that. Number 5, can you assume that plane S intersects plane T at BC? So T is going up and down, S is going sideways. So where is BC? Get my little pen here. So BC is here. Is that where they intersect? Yeah. I got to go back to my arrow. Yeah, that's where they intersect. Okay, and last example. Okay. How do you know that line AB is perpendicular to line BC? Now, if you can't see it, I'm going to draw and point it out right there. That little red corner means that this plane, this line AB, is perpendicular to BC. Explain how you know. That's it. You would write a few. Okay. So now it's time to start the exercises. You're going to go to Big Ideas, do the problems. Best of luck. Ask me if you need help.